So another aspect that is very important whenever we talk about energy is the efficiency, because increasing the efficiency of a certain system will lead to enhancement in the energy production, and this will make it more economically viable because it can produce a larger number of, let's say, a larger amount of energy for a certain consumption that we are putting on the system. So we are trying always to enhance the efficiency of all energy systems that we are using. So let's say if we talk about the renewable energy field, we can enhance the efficiency of use of energy. Let's say in solar PV systems, we can enhance the capacity produced, and then we can reduce then the cost, okay, of the megawatt hour. So this is because of advancement of technology and um, reduction of, if you want, the wrong use of such strategies. We will be able to increase the efficiency of these systems and therefore make them more economically viable. We discussed already before, let's say for a PV cell, what was the main challenge at the beginning. So when we used at the beginning, the problem was that if we reach very large temperature, the energy efficiency will be reduced a lot. And this was the main limitation of using it, especially in countries of very large temperatures. That's why we decided to try to do some heat recovery systems used as a backup for PV systems. So we can, let's say, circulate a fluid in a heat exchanger that can absorb the extra heat of these PV cells. And this will lead to enhancement of their efficiency, plus at the same time use of heat in a useful way, because this heat was rejected and was a waste. So by using the waste in an appropriate way, we can really increase the efficiency, because at the same time the performance of PV cells is better, plus we are using waste heat to in a useful form. So one of the main concerns whenever we tackle any engineering problem is to try to enhance the efficiency of the system, because this will lead to a lot of benefits on the energy consumption level, on the economical level, etc. So for example, we can see here the estimated impact of renewable and energy efficiency on global carbon intensity. Why we expect that larger the energy efficiency of such system, we will have reduction in global carbon intensity, because when you increase the efficiency of your system, you will make your project more economically viable, and this will encourage people to use your system. And since you are relying on renewable energy, you will reduce the consumption of fossil fuels, and you will reduce relying on sources of energy that are not renewable and that can be harmful for the environment. So as we can see here, increase of efficiency will lead to a high reduction in global carbon intensity, and we were able to have 15.1% reduction between 2013 and 2018. So this was a summary of the main energy trends that we are observing worldwide. And we can see from this presentation the importance of renewable energy. And we have an increasing trend for use of renewable energy comparing to a decreasing trend of use of fossil fuels, which is good. And we will try to keep this trend on the right track, and having more and more reduction in the rate of use of fossil fuels and increase in rate of renewable energy strategies. This will require always research, technological development in order to enhance efficiency of such energy system. And at the same time, this will be equivalent to making them more economically viable, and this will reduce the cost, let's say, of production of electricity in case we are using them for electricity, or let's say it will reduce the cost of electrical cars, because when we do advancement in technology, we have larger energy efficiency, we can make increase the production, and this will lead to a reduction in the cost. So this was the session on the trend of energy on a global scale. Now we'll start to look at energy in specific sectors. So we'll start now energy in buildings. Okay, so we'll see uh, how we use energy in buildings, how we can improve the efficiency of use of energy in buildings. So next chapter will be how to implement several engineering strategies in order to reduce the energy consumption and then have more efficient use of energy in building. Of course, we'll talk a lot about renewable energy strategies and different energy strategies that will reduce energy consumption and then, of course, will reduce the need of consumption by fossil fuels, and therefore this will be of economical benefit to the residents of buildings. So to start with, energy and buildings is a very important sector because we know that buildings are one of the major consumers of energy, and we can see that energy is nearly 20% of energy consumption is in buildings. That's why this sector attracted a lot the attention of researchers, how we can reduce the energy consumption, how we can reduce the use of fossil fuels to produce energy for buildings, what can be the different what we call passive strategies. So what are the different passive strategies that can be implemented to buildings in order to reduce their energy consumptions, how we can use renewable energy in buildings, etc. So in this chapter we'll try to tackle all of these questions. Now, as an overview, energy in buildings was a very important field uh, in different ages. So we can see here different buildings, and you can see the variation in architecture. Uh, in all cases, use which materials to use, which architecture to use, what are the different aspects that will affect energy consumption, were one of the main concerns when we build our building. Now, we have different uses of buildings. So we know that we can have, let's say, offices, office spaces, schools, residential buildings, etc. And of course, depending on the use, the strategies will be different in order to use the energy in an efficient way. Now, of course, also the material that we use is very important and will affect a lot if you want the thermal performance of the building. So we have different materials, and depending on the application we have, we select which material to use. So some of the main materials used are wood, concrete, stone, glass and steel, etc. So whenever we want to decide on the building typology, we should explore several issues. First, we should determine the use of the building. If it's a residential building, if it's a commercial building, let's say office, hospital, retail, hotel, restaurant, because depending on the use will decide on the architecture, will decide on the envelope characteristics, will decide on the renewable energies strategies that can be used, etc. So, as discussed previously, the building sector, comprising residential and commercial consumers, accounts for about one-fifth of the world's total delivered energy. That's why tackling use of energy in buildings is very important. And if we can reduce this energy consumption and enhance the efficiency of systems delivering energy to this sector, this will lead to a high decrease in energy consumption and energy cost. Plus, this will reduce, of course, the need to use fossil fuels for energy production. In this graph, we can see the percentage of distribution for the end use sector concerning the percentage of total consumption, we can see that nearly in 2011, residential buildings accounted for nearly 22% of the total consumption. For the commercial part, it's nearly 19%. In industrial field, we have 31% of use, and in the transportation sector, 28%. Now, we'll focus now on buildings. So whenever we talk about buildings, we have the residential track that we are discussing. We can see here the increase in total consumption in the majority of sectors. So from 1950 to 2010, we have nearly, especially in residential, and you can see that, for example, in the industrial field, you have up and downs. But overall, it's an increasing trend. Also in transportation, let's say you have up and downs, but also the overall trend is an increase. In residential case, you can see you have up and down, but really there are very small up and downs and small oscillations. So the overall trend is always an increase in energy use. And that's why it's very important to try to enhance the use of energy in such building and reduce the energy consumption by increasing the energy efficiency of systems, relying more on renewable energy, and reducing the use of fossil fuels. So as you can see here, we are trying to reach like a platform if possible, okay? Because we want to, and after we hope that this energy will be reduced, because if we use highly efficient strategies and we use passive strategies, we'll see what we mean by passive strategies, then we'll be able to have a good performance for the building with much smaller energy consumption. So of course, we should ensure all requirements for a good life, like thermal comfort, indoor air quality, good lighting. All of these aspects should be preserved, but we try to use lower energy to achieve the same goals. So the solution will be to reduce the building energy consumption and sustainability. We already talked about the importance of energy sustainability, and therefore we'll try to design a building that is very efficient on the energy consumption level. To do this, we'll try first to move from an efficient building. When we talk about efficient building, we are using efficient energy systems to deliver energy. And for example, let's say you know that if you go to the heating ventilation sector, you are using HVAC systems, okay? And each heating ventilation system is characterized by a certain efficiency. One possible study, for example, is to see which type of ventilation systems can give you the better efficiency. So it will reduce then the energy consumption. So in this case, you have an existing system that of course might use, let's say, fossil fuels, might use electricity sources, okay, in order to provide a certain energy. If you enhance the efficiency of the system, you will decrease the energy consumption, and then you are doing an efficient building design. Okay, this is very good, but also this is not enough, because you are still relying on resources that you want to reduce consumption of fossil fuels. You want to reduce relying on production of electricity from combustion. So even if your system is more efficient, it's right that you are reducing the need of fossil fuels, but you are still using it because it's the base of your HVAC system. Let's say your HVAC system needs electricity, and electricity is produced or by using fossil fuels or by using other strategies. But what is more important also in buildings than using efficient methods is to go to passive building. What do we mean by this? So we will try to reduce relying on these active systems. When we say active system, you need to provide like electricity to make it work. While for a passive system, you don't need any driving force for it. It's by, it's just whenever it's present here, whenever you implement the strategy by itself, it will reduce the energy consumption. For example, if we talk about the envelope of a building, so once you construct your building, you should design the envelope. Okay, if you use appropriate material with good insulation properties, you will reduce a lot heat flux from the external environment. Let's say in summer, you reduce a lot heat flux from external environment to the inner environment, and therefore you will automatically reduce the cooling load, which will lead to reduction in energy consumption. So, but this system does not need any external source to drive its work. Okay, it just when it is here, it will present a good performance and will reduce heat flux penetration. However, let's say when you use your HVAC system, whatever you do, even if you implement a very good engineering strategy, you still need to supply cool air, and to supply cool air, you need to cool it down from a relatively high temperature. You need energy, and in general, this energy is from electricity. Of course, you can try to, instead of using fossil fuels to provide this electricity for efficient strategies, you can use renewable energy. This is also a good approach. But if you can implement passive strategies, this will lead to a high reduction in your energy consumption. And if you reach the level of implementing several passive strategies, plus you use with them renewable energy, you can reach what we call positive building. A positive building will, if you want, produce energy instead of taking energy. And also we discussed this when we talked about, for example, the electricity grid in Europe. Okay, so let's say in Europe countries, you can connect your renewable energy systems to the grid of the country. So in some days you might have excess. If you use in a very good way passive strategies plus renewable energy, you might have an excess. You will produce electricity instead of needing to take electricity from the state. So this what we try to reach. So we hope to reach positive buildings. In this way, positive buildings can contribute to the energy production instead of requiring energy consumption. Any question? So please, if you want to ask any question, stop me. So what we'll do here in this chapter, okay, we'll define a passive building. What we already tackled is sustainable design, so we can see how the passive building can help into having a sustainable design. What are the main building thermal properties that should be taken into consideration when performing the passive building design? We have a lot of passive building strategies that we will explore. We can talk about passive solar heating, passive cooling. We have energy storage and restitution. We can have strategies for appropriate daylighting. In addition, we'll go over environmental impact of building materials. So whenever we study any project, we should go to the environmental effects and to the economical analysis, because sustainability is related to preserving energy resources for future generations. So we should always pay attention whenever we use any strategy that we are not harming the environment and we are preserving resources to be used for future generation. So in addition to the economical assessment, we should keep in mind to study environmental impact of buildings here. Here we are studying buildings, so we can see what are the materials used. Should not have harmful material for the environment. We should try to rely less on combustion of fossil fuels to reduce greenhouse gases emissions, etc. So we'll do assessment also of building energy performance and efficiency, and we'll go over different energy efficient standards for building design. So we know that whenever we design a building, we have several aims. So first, we aim to separate the indoor space from the outdoor environment. You want to shelter inhabitants, workers, or goods from wind, water, light, heat. We have many other functions depending on the use of the building. So let's say we should keep, of course, inhabitants, and they should be safe. And let's say we want to store goods, they should be in good, the storing conditions should be satisfied to have safety issues. We should keep thermal comfort by ensuring appropriate thermal and humidity control. We should keeping lighting comfort. We should keep acoustic comfort and good indoor air quality. So for example, when we study together how we can simulate an energy system on CFD, we can study the design of a building. We can study the design of a heating and ventilation system, how we can reduce its energy consumption. So the software, the ANSYS Fluent software, will help us to simulate a certain space, to calculate the energy consumption required, let's say, for cooling or heating, or also what is the energy required to maintain a certain level of comfort and level of indoor air quality. So we will learn how to respect regulations on energy consumption and on good comfort and air quality. Other requirement will be the preservation of the structure and the materials of the building. So the building must keep its functionalities and must not collapse or be dangerous to the environment. Now, of course, whenever we want to design a building, the main aspects to consider will be the size and the volume. You know, what is, if you want right place to put our building in, the external appearance, the functionalities, the accessibility, the structure, the modularity, the materials, etc. And whenever we do the design, we should take into consideration the lifetime of the building, the economical costs of the building, its performance, the level of quality of and the living condition inside it, the environmental integration, and the environmental impact of the building. So you can see always, as we mentioned, different aspects that are considered in any design. And here we'll apply them on the design of building. So we already discussed the economical aspect, the social aspect, and the environmental one. So all of these aspects should be considered whenever we do any design. And here we can see that the main parameters in the design are related to these three aspects: economical, social, and environmental. Now, when we talk about passive design, a passive design is an approach to building design that uses the building architecture to minimize energy and improve thermal comfort. So when you build your system from zero, if you follow completely regulations, you can come up with a passive design, and you can tend to have also a positive design. Now, a passive design has several advantages. First, it helps to reduce or even eliminate utility bills. So on the economical level, this is very important. Having a passive design is very important on the economical level because it will eliminate utility bills, it will reduce the energy consumption, and this is why people will tend to invest a lot in such sector. It will improve the comfort and quality of the interior environment. It will reduce, so on the environmental effect also, it's very interesting because it will reduce greenhouse gases emission associated with heating, cooling, mechanical ventilation, and lighting. On the social level, it will improve the comfort and quality of the interior environment. So you can see here that all aspects, economical, social, and environmental, are tackled when doing the design. It will reduce the need for mechanical systems. Whenever we talk about, as I told you, a mechanical system will need external intervention to work, and you need to supply electricity, you need to supply energy for it to work. This is why we call it active system. However, any other strategy that will perform its work without external intervention is a passive strategy. So once you invest in it, once you implement it, it will work. okay, and it will not need external intervention to make it work. So this is passive strategy. So a passive design will try to reduce the need for mechanical systems, therefore reducing the resources required to manufacture these systems, as well as the costs associated with their purchase or operation. So as you can see, economics are involved everywhere whenever we do a design, because what will make us select our choices is mainly the economical aspect, of course, in addition to social and environmental. Now, if we talk a little bit about regulations, whenever can we consider that we have a passive design? We discussed together last time that it's not easy, of course, to go back to go to zero need of electricity. We'll always need electricity, but this electricity need can be reduced a lot if we use a passive design, and higher the level of passive design, lower will be the electricity consumption. And if we can profit, if you want, from all possible strategies plus renewable energy, we can reach the stage of positive building, which will produce electricity instead of consuming electricity. So this is our final purpose. But until now, we can define a passive design with standards. Okay, for example, the most rigorous European standard for passive houses in Germany regulates that input energy should be maximum 15 kilowatt hour per meter square per year for the heating, cooling, and ventilation field. While if you take a non-passive building, you can reach really much larger values. So this is an acceptable, a very acceptable electricity consumption for heating, cooling, and ventilation. Of course, we can try to reduce it more and more to tend to go to a positive building. On the other hand, we also put a regulation on the total primary energy use for all appliances, including domestic hot water, space heating, and cooling of less than 120 kilowatt hour per meter square per year. So whenever I am constructing a building and I want to say it's a passive building, I should try to I should satisfy these conditions. So the total primary energy will include the efficiency, of course, of the energy generating systems. So it is the total energy that I need to supply. Now, energy consumption of a typical new 200-meter square Canadian house, you know that, for example, in Canada, we implement a lot of passive strategies. Okay, so this will lead to less energy consumption, which is equivalent to 300 liters of oil, 300 meter cube of natural gas, or 3,000 kilowatt hour of electricity per year. This can be achieved by high level of insulation with minimal thermal bridges. So here, when we talk about thermal bridges, these are sources of leakages of heat. Okay, so we try to increase a lot the level of insulation to reduce interaction between the indoor and outdoor. You know, especially in climate like Canada, you have very small, very low temperature outside. So you need to work a lot on the insulation levels of your envelope to reduce the need for heating load within your building. High level of use of solar and internal gain. It depends, of course. For example, let's say in a country where solar energy is widely available, one of the best strategies is to use solar energy. While let's say in countries where you don't have a lot the sun, you can go to wind energy, you can go to hydro power, etc. We should try to ensure a high level of air tightness and a good indoor air quality while preserving a good indoor air quality. Now, we already discussed together the design process, and now we are applying it for a specific energy project, which is the design of energy in buildings. So whenever we want to design a building, we should make sure of efficient use of energy. This is why we need a design team to cover all possible aspects, and the interaction between members of your team will make your design better and better. So always the design process should be interactive between the different aspects. So let's say the mechanical engineer should interact with a cost consultant, with a project manager, with an electrical engineer, an interior design, an architect, etc. So let's say the architect will help you to select the good orientation of your building. Electrical engineer will try to use sources, let's say whenever you want to use a type of lamps or types of lighting, you will use a type that will not consume a lot of energy. The mechanical engineer will suggest for you some ventilation systems that are characterized by high energy efficiency and by low consumption, etc. So whenever we do a design process, we should avoid the linear process. So what is the typical linear process? We have the architect that will put the first sketch for the building, and it will give the sketch to the engineers without a lot of discussions. Then the mechanical engineer will just take concern of the HVAC system by sizing the equipment and verification of compliance of equipment with regulations, while let's say the structure engineer will study the structure of the envelope, will verify the compliance with regulations. But this is not very efficient because sometimes you need to interact between these three main members, in order to tackle some unexpected issues, or you can lead to better, if you want, energy use. So we hope at the end to have integrated and recursive work. So as we discussed in the design process, sometimes we need to redesign from zero, because whenever we go through the project, we have some unexpected issues that will come out. So it is a very important thing is to have iterations and to have interaction between the architects, the mechanical engineers, the structure engineer, etc. And we should perform always some preliminary simulations and do some analysis together in order to enhance the design. Now, concerning the performance of a building, we have several ways of evaluation to answer, and we should answer several questions whenever we do the design. First, what are the functionalities of the building? Because this will affect the design of the building. What is the comfort level required? Of course, let's say if you design, for example, an office space, you are mainly concerned with comfort during the day, because the time, in general, in office spaces, the working time is, let's say, from 8 to 5. So you can focus your design for these hours. You don't care a lot during nighttime what will happen. So you can put the orientation in a way to ensure, let's say, whenever you have sun hours, a good sun penetration between these times. You can choose the orientation in a way to reduce heat flux during summer, etc. Now, the energy consumption of the building also is very important to know, in order to assess what are the strategies to be implemented. Whenever you want to include renewable energy, to size your, let's say, solar system, the number of PV, let's say you want to use PV, the number of PV arrays you should use, PV panels, what are the batteries needed for energy storage, etc. What is the level of the environmental impact caused by the building? As we discussed, whenever we do a design, we should tackle economical, social, and environmental effect. So we should always make sure that we are not causing harm effects to the environment. And of course, on the economical aspect, we should study the cost, study the investment, and make sure that we are, the incomes will be able to repay the investment in a certain acceptable period of time. So all of these requirements and the design should fulfill the specifications of the general contractors, expectation of the occupants, and of course the requirement and regulations. So when we will talk about energy policies, about regulation, we will see that we'll always have to stick to these regulations for optimal performance of the building. So we should use precise definitions, measurements, and evaluation tools that are needed to answer all of these questions. So for example, here we have already regulations for passive buildings. We have numbers. So we should, when we design, we do simulation, we should make sure that at the end, we verify that we are below 15 kilowatt hour per meter square per year for heating, cooling, ventilation, and below 120 kilowatt hour per meter square per year for the total primary energy use. If not, we can try to include more passive strategies to rely more on renewable energy until meeting these requirements. And of course, it's not enough to meet these requirements. We have to meet them with a lower cost. So that's why we will study several alternatives before selecting the best one, which will satisfy these and at the same time will lead to benefits over the lifetime of the project. Here we discussed, if you want, also possible project topics. We said that we can study with a certain software, let's say Energy Plus, or any other softwares that can simulate heating, cooling loads, how using several passive building strategies, by combining them, how we can reach passive building, and we should know also how to perform an economical analysis to select the appropriate method between all of these. Now, of course, whenever we talk about the social effects, so we should make sure that the occupants are in comfort. And we talk about hygrothermal comfort, so we should have good humidity levels and acceptable temperature levels. So thermal comfort is a very subjective term, therefore making it difficult to model. We'll learn also, when we do energy simulation of buildings, we'll learn how we can test the thermal comfort. I will give you several tools, simple tools that will help you to assess comfort, to make sure that people will be comfortable in a certain building. And we'll see how sensation linked to the thermal balance on the human body and environment can be performed. You have some online calculators that can give you numbers to assess the thermal comfort sensation. And also, of course, we have very complex bioheat models that are programmed and developed in order to test thermal comfort. We'll discuss all of these together when we do simulation of energy systems using ANSYS Fluent. So we can see that the comfort, of course, will be influenced by air and walls temperature, by the humidity, the air velocity, the closing level, the direct solar radiation, the metabolism and physical activity, etc. So it's really challenging to study thermal comfort, but we'll develop some tools that will help us into assessing comfort in buildings. Now, we always can define a certain comfort zone. And of course, this zone will depend on persons. And if you take now a person, let's say from Canada, the sensation of comfort for this person will be completely different than a person from Africa, because they are already familiar with different type of climates. Okay, so this of course will affect